Okay, example A asks us to find the sine, cosine, and tangent of angle A. So angle A is up here. In order to find the sine, cosine, tangent, which we're going to use SOHCAHTOA for, we need to find the missing side. So we're going to have to use our Pythagorean theorem. So we'll have 5 squared plus 12 squared equals c squared, since the long side is the one that's missing. So we have 25 plus 144 equals c squared. 25 and 144 is 69, or 169 I mean. C squared. So we take the square root of both, and we get 13 equals c. So that tells us that our long side there is 13 units. I'm going to delete this so we have a little more room in a little bit. So we're 13 units long. So now we need to find the sine, which is opposite over hypotenuse. So if we're dealing with this angle, the opposite side is 12. So we have 12, and the hypotenuse, of course, is always the long side, so that's 13. And that's it. It's just that comparison, 12 to 13. Cosine is adjacent over hypotenuse, so we deal with this the side that's next to the angle, adjacent to it, 5 divided by the hypotenuse, 13. And then tangent is opposite over adjacent, so we have our 12, which is our opposite side, divided by 5, which is the adjacent side, 12 over 5. Yeah, that's it. We just have to find those ratios. Then for example B, we have find sine, cosine, and tangent of angle B. So we're working with this angle down here. Again, we're missing a side. In this case, we're missing the middle side. So we have 5 squared plus b squared equals 15 squared. So 5 squared is 25 plus b squared equals 225. So b squared equals 200. So b is going to be the square root of 200. Now we could run that through a calculator, get something like 14, or we could reduce that and say that b is the square root of 2 times 100, and the square root of 100 we know. So we can take this out and put the 10 outside, and we'll get b equals 10 square roots of 2. So we have 10 square roots of 2 up here. And now we can do our sine, cosine, tangent. SOHCAHTOA. So sine is opposite over hypotenuse. So we have our new side we just calculated. Sine is 10 roots of 2 over hypotenuse, which is 15. Let me make room for that reduction there. We know that those both reduce by 5, right? So we have 10, oops, I left a little nub there, there we go. We have 10 and 15 both reduced by 5, so we have 2 roots of 2 over 3. That's our reduced figure. And then cosine. Cosine is adjacent over hypotenuse, so the adjacent side is 5, and the hypotenuse is 15. Well, 5/15 reduces 2, that's 1/3. And then tangent. Tangent is opposite over adjacent, so we have the opposite side, our 10 roots of 2, divided by our adjacent side, which is 5. 10 roots of 2 over 5. 10 and 5 both divide by 5, so we get 2 roots of 2 over 1, if you like, or just 2 roots of 2. And that's it for that one. And then example C. Example C asks us to find sine, cosine, tangent of a 30-degree angle. Now this one's actually easier, because we know if this is 30 and this is 90, since it's marked, then this one over here must be 60, because we can only have a 180-degree triangle, right? So a 30, 60, 90 triangle, we know the ratios for. We did those in a prior lesson. The bottom side would be x units, which means the long side, the hypotenuse, would be 2x units, and the left-hand side would be x roots of 3. So since we know the short side, x, that means that this side, the middle side, y, would be 6 roots of 3, and then x, the hypotenuse, would be 12, 2 times 6. So now we can do our SOHCAHTOA, and we're dealing with a 30-degree angle, so we have opposite, 6 over hypotenuse, 12. So the sine is 6/12, or 1/2. the cosine would be adjacent over hypotenuse, so 6 roots of 3 over 12. 6 square roots of 3 over 12, and that reduces, 6 goes into 12, so we have root 3 over 2, and then the tangent is opposite over adjacent, so it's going to be 6 over 6 roots of 3, 6 over 6 roots of 3, which reduces, so we get 1 over root 3, and then we have to reduce that by taking the root out of the denominator, remember? So we'll multiply top and bottom by root 3, and we'll have 1 times root 3, or just root 3 on top, and then we have root 3 times root 3, or 3, in the denominator. There we go.